Ladies, we're looking at section 4.1, goal 4, use angles to model and solve real-life problems. So in the previous lesson, we talked about the fact that to find an angle measure in radians, given arc length and radius, the angle theta is equal to the arc length s divided by the radius r. And we discussed that this is the definition of a radian. So to calculate the radians of an angle, given arc length and radius, we use s divided by r, and that gives us theta in radians. At the same time, we want to be able to use this formula to calculate arc length or radius length. And it's important to note that when you are calculating arc length or radius length, that you understand that theta is always should be in the form of radians. Theta should be in radians because this formula calculates theta in radians. So let's look at this example. It says, given a central angle of 214 degrees, find the length of its intercepted arc in a circle of radius 12 centimeters. All right, I want to draw a picture of you so you can see that. You can draw a picture also if you'd like. Okay, so here we have a circle, and I'll draw an angle of roughly 214 degrees. So this angle is 214, and it represents theta. We're also given that the radius is 12 centimeters, and it's asking us to calculate the arc length, which remember is s. So if we begin with our formula, theta equals s divided by r, and solve this equation for s, we have s is equal to theta radians times r, which is the radius. We have everything we need. So our arc length is our angle measure, which is in degrees. Because this is in degrees, we have to convert to radians. Remember, to convert degrees into radians, we multiply the degrees by pi radians divided by 180 degrees. This will give us our theta in radians, and then we multiply that by our radius of 12 centimeters. Okay. You can take your calculators and multiply and find your solution. Please make sure that you round to the hundredths place. So work this out right now and double check. You should have 44.82 centimeters as this arc length. What I'd like for you to do right now is turn to the 4.1 practice handout that we worked on today in class and find part 4. That is your homework, and I'm going to work through a couple of those problems with you. In each of these homework problems, you're repeatedly solving for arc length on a circle. So let's review our formula. Theta radians equals arc length divided by radius. So if we're solving for the arc length, let's go ahead and rearrange our equation. So we have S equals theta radians times the radius of r. And if you'll put the word radians after theta, hopefully that will help you to remember to always convert degrees into radians. So the arc length is outlined here for you in black. So the arc length is equal to 315 degrees. Because this is degrees, we must convert to radians. Remember, we do that by multiplying by pi over 180. And then we multiply that by 11 feet. All right, I'm going to pause this and give you a moment to calculate the arc length. Come back in a second and check your answer. Okay, for example 1, you should have an arc length of 60.5 feet. Please pause the video for a moment and set up your equation for number 2, and then come back and check your equation before you calculate the arc length. All right, so let's see how you did. S equals 270 degrees. Because it is degrees, we do have to convert to radians, so multiply by pi over 180, and then times the radius of 13 feet. And if you got that correct, you can go ahead and calculate. So go ahead and pause again and calculate your arc length. And you should have calculated an arc length of 61.3 feet. I'm going to work one more example with you, and then I'll leave you to finish this handout for homework. On example 3, our arc length is shown here. And this time we're given theta in radians. Because theta is already in radians, we do not have to take the time to convert. So that's 3 pi over 2 times 16 feet as our radius. And so we calculate that as 18.8 centimeters as our arc length. Please make sure that you complete 4 through 8 for homework tonight, and I'll see you tomorrow. Thank you.